Yeah, so let's say we're given this question, right? The question says we need to prove that the limit of n approaching infinity of a of n bn is equal to ab. So now what we need to do is for us to prove this theorem. Yeah, I was trying to shift where I was. These people are making noise. I'm looking for a nice place with nice connection. Yeah, so we're given the limit as n approaches infinity of a n bn, which is equal to ab. So for us, no guys, mute your minds. So for us to prove this, we need to first say, if we are given, or we say for any epsilon greater than 0, they exist. Here we should use they exist, right? They exist. So obviously there will exist an element of a natural number, such that we'll have the absolute value of an and bn minus ab, which is less than a. So now what happens here, let me do this. What happens here is that now I need to start from this part where I say now, right? So remember, every time we prove such questions, I prefer that we start here and say now. Then we say now the absolute value of a of n bn minus ab will be equals to. So check this. We are multiplying an by bn, which we say that is equals to ab, right? So for us to solve this, best solve this, here we can just try to take a times b, take the opposite. Let's take a times b, or someone would decide to take b times a, right? So we're gonna take a times b. First we're gonna say an bn, we minus an times b, right? Plus we add again an times b. You see, right? Then this will be minus, you subtract this now, ab. And using triangle inequality, we'll get that this is less or equals to an bn minus an b plus an b minus ab, right? Which this is equals to, I can factor out an this side. I'll have bn minus b plus, yeah, I can factor out b. I can have an minus b. So let me erase this one down here. So let me put the absolute here. That's fine. I want to try to put the absolute here. Absolute values. So I'm gonna put an absolute. Yeah. So from here we know this, right? We know from I'll write with a different pen, right? We know that we have what we call, say, from boundedness.
So
Yes.
why is it by the last step you said you factored out b, but then there's still a b there?
Oh, there's still a B.
I was thinking-
Oh, yeah, it's a mistake. If there's still a B, it should be A, right? Ne? Yeah, I made a mistake there. It should be A. Thank you for that. So we know that from boundedness, we say that the sequence is bounded if and only if we say that a of n, I'm just gonna summarize it, right, is bounded if and only if the absolute value of an is less than or equal to m. You see, right? So we have this. So it means that we are allowed to replace this by m. And then again, if the absolute value of b is less or equals to, so let me do this. If we have b, right, as the least upper bound, right, as the least upper bound, any value above it will become this one will be, it's either it can be the supremum, so we're allowed to have values above. So I think these values here, we're going to have, let's say, the interval like this. We're going to have the absolute value of b plus 1 to infinity. Having a bound, or let's say we say that something is the least upper bound, we are saying that there can exist a number that can be the upper bound, but then we are taking this one as being the least or the smallest. Remember, when you conclude on those formal definition of a sequence, you say that we may choose some positive, you may choose n to be the smallest positive integer, but it doesn't necessarily mean that it is the highest or the max or the only integer, but we are saying that we are choosing it to be the smallest, assuming that there may arise some integers along the way, right? So we are also saying here that we can say that since we have the absolute value of b, we can use the inequality to say that this is less or equals to b plus 1, as long as it's going to align with this. You see, right? So now, now we can come and say this. Let me erase this. So it's fine. Now we can say this. We can say this would imply that the absolute value of absolute value of bn minus b plus the absolute value of b times the absolute value of an minus a will be less or equal to, we know we'll substitute m on that, right? We have bn minus b plus, here our b, we replace it by, we can say, let me say this here, absolute value of b plus 1 times the absolute value of, I'll just write it down here because of space, an minus a. So let me remove this. I need this question right, but it's fine. I know the question by heart. Let me just erase it. I'll just erase it because I need this question. So here we know again that since you're saying, we know again that since the absolute value of a of n minus a is less than e over 2, right? This can also imply that the absolute value of a of n, let me say this, it's because of space. I'm going to explain this, right? So we know that the absolute value of a of n minus a is less than e over 2, right? But we can be allowed to say this. Let me say this. We can be allowed to say this. We can manipulate the denominator. I see. This would still remain less than e over 2, right? Again, so you're going to manipulate it according to what you need. So let's check what we need here. Where there's this a of n. What we need where there's a of n is absolute value of b plus 1. So we can say that e over 2 times the absolute value of b plus 1 on the denominator. We can only manipulate the denominator, because once you manipulate the denominator, it doesn't make a huge difference, right? And then we say this is less than what? E over 2. but we're interested in this part. You see, right? And since the absolute value of bn minus b is less than, this would be less than what? E over 2. But this E over 2 is greater than E over 2m. You see, because where there's bn minus b, I need m. So I'm going to put m there. And this would imply that the absolute value of, or this would imply that m, so I'm taking this. This would imply that m times the absolute value of bn minus b plus absolute value of b plus 1 an minus a. This should be less or equals to, right? Then, but since I'm gonna substitute this one of less, right, I'm gonna remove this equal sign. So you'll see on the other PDF which I sent, I've structured them well. Here I'm just explaining, so I need to include some things which I didn't include in that PDF. So I'm going to say this is less than, what is this? It's m times e over 2m. You see, right? Plus this is absolute value of b plus 1 e over 2 absolute value of b plus 1. Then that will cancel. This will be equals to e over 2 plus e over 2, which is equals to e. You see? So I've proved this. Any question? So I proved this. You see, right? I proved indeed that this is indeed less than e. Right? So if you want it to be structured in a nice manner where you're just going to come and say this is less than m absolute value of bn minus b, you can check the other PDF. Then you just add your one, put it inside brackets. You can check the other PDF which I sent. So, okay, in the absence of questions, I'm going to say this. Now we have this. Okay, let me see. Okay, let's discuss this question, then I'll come to that one again. So we have this question. It says that show that the sequence defined by a1 is equals to 1, a of n plus 1 is equals to 3 minus 1 over a of n is increasing, and a of n is less than 3 for all n element of natural numbers. Then says also deduce that the sequence a of n is convergent and find its limit, right? So let me erase this and explain what is happening. So remember, here they said this. They said we should show that the sequence defined by this, right, is increasing. Even though they said increasing, I prefer that, let's check the increasing part, that we say a of n plus 1 minus a of n is equals to, don't say greater or less, we're going to use this method. So when I say is equals to, what I know about a of n plus 1 is this, right? So I'm going to write 3 minus 1 over a of n minus this a of n. Alright, minus a of n. Alright, this would be 3 minus, this would be 3 minus a, this times this, yeah, it's fine. I'll say this 1 minus a squared n all over a of n. So the question is this. Here we're given that a of n is less than what? 3. You see right now? We're given that a of n is less than 3. So since the a of n is less than 3, I must plug any number that is less than 3 here to check whether this is going to be greater than 0 or it's going to be less than 0. That's when we can decide whether it's increasing or decreasing. So what I'm going to do now is plug 2. Let's try to plug 2 and see. If I plug 2, I'll have 3 minus 1 minus 2 squared all over 2, which this will be 3, minus, this will be 4, 1 minus 4 is minus 3 over 2, this will be positive, 2 will be 3, plus 3 over 2, which this would be 6 plus 3 over 2, which is 9 over 2. So you see that it's positive, right? This would be greater than 0. So this simply states that this thing is increasing because we found that it's what? Greater than 0. So now I'm just going to write greater than 0 here. You have shown that with your calculator. You don't write it here, you show with your calculator. You check with your calculator, find that it's greater than 3. You're greater than 0. So I wrote greater than 0 there. Then I come and say, therefore, a of n plus 1 is greater than a of n. Because if this is greater than 0, I can take this to the other side. You see, right? Then I'll have this. So from here, I can say, hence, a of n is increasing. So we come here to the second one. They said we should check what? We should also deduce that a of n is convergent.
Can I please ask?
Yeah. Yes. I can't hear you anymore.
That part where we're proving for the a of n is increasing. The second step here where we have a denominator of 1 minus a squared n. Did it come because we found the common denominator of a divided by n minus a n?
Yeah, I took this by this. It's a squared n. And then I said 1 minus the multiplication of this all over that. You can do it anyhow. It doesn't matter how you simplify.
Like finding a common denominator would work.
Yeah, it would work also. So, can we do the part of convergent? So here's what I can tell you, right? Sometimes they'll say deduce that a of n is convergent. Sometimes they'll say deduce that a of n is bounded. You're gonna do it the same way as long as they give you these restrictions. You see, right? So, even if they say it's bounded, what you must do is just show using mathematical induction. So we're gonna say since a of 1 is equals to 1, hence so let me erase this and then I'll write it again so that you can see when I'm writing. I think it would be best if I erase. Yeah. So check this. We're given this. We're given that a of 1 is 1. We're given a of n plus 1. So, and also we're given a of n less than 3. So check this, right? When you're proving mathematical induction, you prove in 3 steps. First, you must prove for n equals to 1. Secondly, you prove for n equals to k, and this one is assumed. You see, right? Then you deduce that n is equals to k plus 1. So you're deducing that this one is also true. So this is what we must do now to prove that this is convergent. So now we're going to say this. We're going to say for n equals to 1, a1 is equals to 1, which is true for all n. You see, right? So I just took the first part. If n is 1, then we'll have this case, right? We should be true. Then secondly, we suppose, now we're saying that n is equals to what? N is equals to k. For some, always you must say for some. K element of, we check, did they say a natural number here? Natural number, which is this one. So we're gonna say, suppose k is an element of a natural number, then we'll write IE. Then this will be, we have that a of n is less than 3, so we're gonna make it a of k less than 3. Right. Then other ways here, we're trying to say that this thing converges to a limit, and that limit is 3. You see, right? That's what we are saying in this case. Then after supposing n of k, we have to deduce n is equal to k plus 1. Right? Is also true. So here I can say, suppose n is equal to k is true. I can include that part of is true. Or let me do this. You can see is true for some. Then here to deduce this, I'm going to say i.e. I have a of k plus 1 is also less than 3. I just exchange that by k plus 1. Then now what I should do, every time you're working with inequalities, you should start from assumption to prove that this is true. So I'm going to start from assumption. Our assumption says that this is what? So let me put here assumption. Our assumption says this, that a of k is less than 3. And keep this in mind, that a of n plus 1 is equals to 3 minus 1 over an. And this would simply mean that a of k plus 1 will be equal to 3 minus 1 over a of k, you see. So now I must derive this to this, to this. You see that? So that's what I must drive it to. So it means that for me to drive that, I know that I need this to be negative. So I can multiply by negative both sides. I'll have minus ak, which is greater than 3, or minus 3. You see, right? And now I need to flip them. If I flip them, the sign will change also. The inequality sign to face the other side. You see, right? And then now I need to add 3 both sides. So I can add 3 here. Then I have minus 1 over 3 plus 3. Which this would imply that, okay, before I imply, let me just remove this. I'll just remove this. So I have this, right? Then you know that this one is the same thing as having k. So that is the same thing as having k. That is the same thing as having k. So this is the same as k, you see. A of k plus 1. So say a of k plus 1 is less than, what is this? Minus 1 over 3 plus 3. This would be minus 1 plus 9 1 over 3, which should be 8 over 3. And this should be 2,66 something. So this would mean that this is 8 over 3. And this is less than what? 3. Is right. Then this would imply that a of k plus 1 is less than 3. Hence, or thus, the statement is true, is also true for some n equals to k plus 1. I can just do like that. Then I say hence, they said we should deduce if it converges, right? A of n converges to 3. You see, right? So given that a of n is less than 3. Any question? Any question?
I couldn't understand that part with the with equality. That's from 1 divided by a k is less than 1 divided by a k. I couldn't understand what happened afterwards.
I got it here. We are given ak minus ak is less than 3, right? Then we know that we must supposed to change this to this. We should drive it to this. So what we need is, we know that this AK is minus, it's negative here. So I need to first multiply by a negative, both sides. You see, right? Then every time, if I multiply, the things that change the inequality sign, right? If I multiply by negative, the inequality sign will change. And if I inverse, it will change. You see, right now? So, what I did here, I just multiplied this by negative first, negative, the sign changed to great, you see. And then I inversed, then it also changes back. You see, right? After that, then I realized that, oh man, this now is the same as this. You see, what do I need next is to add 3. Then I added 3 both sides. I have this and this. You see, right? And I know that this one is equal to a of k plus 1. Then I substitute that, it's here. I substituted on the left. And then this side, I just calculated and say that this is 8 over 3. And I know that 8 over 3 is less than 3. So I can just decide to take this. Because that's what I was trying to prove. Do you agree? Yeah, then that's why I said that the statement is true. It's also true for n equals to k plus 1. And also, this would deduce that a of n is convergent. And it converges to what? To 3. So, the last question they said, we should find its limit. So, for the limit part is simple, right? Let me just not write this one. I did what? I did let the limit. Yeah, you should. There are many questions like this. Doing them, it would help us grab this format. Because that's the format that we're looking for. Okay, right. So now we come to finding the limit. So let me erase this. I don't want to erase this, but I think let me just erase so I can explain it while I'm writing. So, because I don't have a calculator where I am and can't calculate such things. So here, to find the limit, right, we have to do this. We have to suppose that the limit as n approaches infinity of a of n will be equal to L. We're saying that this limit will approach L. It means that it should exist. That's what we're saying. And this will be the same as the limit as n approaches infinity of a of n plus 1. Right, so what I'm saying here is that if n is equal to 1, a1 will be approaching L, a2 will be approaching L. So this will be a2 if n is 1. So these are the same thing. They're in one function, which is what? an. You see, right? So it's one thing. That's why I was saying that they're all approaching the same number. It's equal to that number. They would all converge to the same number. So even if we were to get A3, A4, A5, they would all converge to L. Then since we're given this, right, and we know that A of n plus 1 is equal to 3 minus 1 over A of n. This would imply, I'll write on the side when we have no space left. So this would imply that this is L is equal to 3 minus 1 over L. And if I multiply both sides by L, I'll get that this is L squared, which is equal to 3L minus 1. Then I take this to the other side, right? I'll have L squared minus 3L plus 1, which is equal to 0. But I can't solve, I simply can't solve this, right? I can't factorize this. So what I should do, since I can't factorize, I should use, what's this? I should say L is equal to quadratic equation minus b plus or minus, b squared minus 4ac, which is all over 2a. Given that our a will be 1, which is this, and then our b will be minus 3, which is this, and then our c will be 1, which is that there. Then I'll have here left that L will be equals to minus 3 then we have plus or minus the absolute value of minus 3 squared plus 4 1 all over 2 1, right, which this would be 3 plus root of 9 plus 4. 9 plus 4 is what? Is it 13? Oh, it's minus. It's minus. It's not plus ish. Why did I put plus here?
Yeah, it's minus, which is 3.
9 minus 4.
Which is 5.
Yeah, all over 2, right? Plus or minus here. So, but I'm gonna write this and then I write or 3 minus. You understand why I did this, right? Because we had plus or minus there. You see, right? So L will be equal to this. But we are increasing here. Remember, this will be smaller, this will be big. And our sequence is increasing. So it means that we'll take the bigger one. You agree, right? Therefore, L will be equal to 3 plus root of 5 over 2, which is equal to the limit as n approaches infinity of a of n. It's right, since the sequence a of n is increasing. You see, right? Then this will be the case. Any question? I'll put it like this so you can see. I still have another question that is similar to that. Any question? So let me erase this one. Here I was trying to show the computations. Yeah. Any question?
Therefore, L equals to 3 plus root of 5 divided by 2 equals limit of n approaches infinity of a. And do I need to write the right side of it?
Yeah.
Am I taking it from that point? Yes, suppose.
Yeah, you're taking it from here. You see, right? So now we have this. We are given this question now. They say a of n is defined by a1 will be, this will be equals to 1, and erase this question. Let me write it. I think it should be 4. Let me check. Yeah, 4 plus this, yeah. So we have this question, right? And we say it's defined elements of positive integer. This is the same as natural number. And then they say we should use PMI, which is the principle of mathematical induction, right? They say use PMI to prove that this, right, a of n is in between that. Then for all n element of positive integer, and they say show also that a of n plus 1 over a of n is greater than 1, which means that we must show that it increases for all n. Then I said deduce that a of n converges and find its limit. Is it that the question will always come the same way? It will always come like this. Then first what you need to do is you need to prove that this, using mathematical induction, obviously you're gonna have for n equals 1, you check your a1, which is 1, which is true for all n, right? And then you suppose that n is equal to k for somewhat k element of integer plus, because that's what they defined it on here on the question. Then from there we can say IE. Then this one I'm gonna write from assumption, because we know that we need to take it from assumption. This is assumption. Let me not write from assumption. I'll write assumption because this is our assumption. All right, assumption. And then we deduce that n is equal to k plus 1 is also true. It's also true. You see, right? Then I can have this. So the aim now is to take this assumption, change a of k to this. You see, right? That is the aim. That's what I did before. I took a of k and changed it to this. Then I can substitute a of k plus 1 there. And I must find that it's less than 8. That's what I'm interested in. You may find out that this one changes. Most of the times this one will change, but this remains the same. You see, right? So when we come here, we deduce that this is like that, and we take it from assumption. Here we took from assumption, we had our assumption is this. So from assumption, you see, right? I took this from assumption, is from the assumption. Always remember those who are our teaching mathematical inductions, that every time you're dealing with inequality question based on mathematical induction, you should always take it from assumption. So take it from assumption, then I check here. Once I wrote this, you should always write this somewhere where you can see where should I arrive to, right? This is the destination. So first I know that a of k, first manipulate a of k. A of k is to the 1 over 3. So I must say 1 over 3, 1 over 3, 1 over 3, to the exponent 1 over 3 on all sides. You see, what is done on the left hand side is done on the right hand side. Then after having that, I just simplified here that, okay, this will be the solution for this. Then now next I need to multiply a of k to the 1 over 3 by 2. Then I did it also on the left hand side, which is this, here which is this, here also which is this. The next I need to do what? Next I need to add 4. So I added 4 on the left hand side. 2 plus 4 is 6. I add 4 here, which is this one. Then 4 plus 4 is 8. You see, right? Then I arrive to that. Now check this. Check this. This is the same as a of k plus 1. You see, right? That's why I substituted a of k plus 1 there. Hence, I've proven that this is the case. You see, right? I say that statement is true for some k element of positive integer. Hence, I can say that this one is in between. You see, right? That was the first condition to prove. So I proved this. Any question from this? So I didn't want to erase this one because I've already explained it from the beginning. Now I just needed to explain again here on what to do. So do we agree on this, guys? Or if there's no question, I think we can do this. Yes. I must do what?
You please slow down.
Oh yeah, sorry about that. It's when you're having this thing, you move, you write fast. I didn't realize that. Okay, so we'll come to. I took some question here. You're saying?
The air around you sometimes tends to be a little distracted. Sometimes your voice goes down.
Oh, the wind around me. Oh, but now you can hear me, right? Can you hear me? All right. So let's check now. The second question says we should show that this is the case, right? That means that for this we have a of n plus 1. What is our a of n plus 1 here? Is 4. So for us to show this, the best way is this, guys, is to say this a of n plus 1 minus a of n, right? Then we know that our a of n plus 1 is 4 plus 2 a of n to the 1 over 3. You see, right? Then I subtract a of n. So since here it might seem to be difficult to factorize, I can just decide to take here our value saying that a of n is less than or equals to 8, right? So I can take 7. Let's take 7 and plug here. Can someone, or maybe 8, let's just plug 8. If I plug 8 here, and I have 2, 8, 1 over 3 minus 8, which this would be minus 4 plus 2 times 2, which this would be what? Would be 0, right? Yes. Then I plug, because I want to see whether it's increasing or decreasing. Now I just found that this can be equals to 0. So now I can plug 7. Let's try to plug. Anyone who can plug 7 with a calculator and check what it will give us. Let's plug 7 here. We are plugging 7 on a of n. So I'm taking the values that will agree with this inequality, the restriction. So I can either plug 8, 7, 6, up until 1. You see, because they're included. So let's plug 7 and see what we get.
0,83.
0,83. So this is what I was interested in. So we found something here. Is this value less than 0 or is greater than 0? Is this value less than 0 or it's greater than 0? It's greater than 0, right? So it means that what we know is that this thing is increasing. So we can say this. It's increasing. So I'll say this is greater, but I won't say greater only. I'll say this is greater or equals to 0, because we show that we've seen that when I plug 8, I get 0. So 0 is also included in this. Therefore, a of n plus 1, I can take the a of n to the other side. You see, right? Hence, a of n is increasing, which is the sequence, right? I'm gonna put this. So the sequence of a of n is increasing. So we've shown that. Is there any question? Yeah, after here I'll upload the recording. It doesn't take time, like takes less than 10 minutes to be uploaded. So is there any question on this? All right, if there's no question, we can do this. Now we know it's increasing. We must find what? We must find the limit now. Oh, it's increasing. Yeah, we found that it's increasing, and we found that this concludes, right? So the next question is says that we should deduce that a of n is, it converges. So check this. To prove that this thing converges, we use this proof, right? This one. So I've already proved this. Now I just need to come and say, since the limit is increasing, and this, and also by, I can say by induction, a of n is between 1 and what? And 8. I've proved this right now. And a of n is increasing, right? Then a of n is convergent. You see, converges to what? To 8. So that's what we're interested in. Say if it was decreasing, it would converge to 1. So since it's increasing, it converges to 8. It increases, but there's a certain part where it doesn't pass, right? Which is 8. We agree, right? Then which is this. So from here, now let's do this. You see, right? So nice thing about this question, guys, they did this. They just did this. They just took this and they separated it from this, just to see what you'll do. They want to see your understanding, right? So someone would solve this. After solving this, they'll be stressed. How can I solve this? I've already shown that it converges to 8 because it's increasing, right? So you're good to go. Usually they would start by asking you whether it's increasing or not. Then they ask you this one. It makes sense to come and say it converges because already you know, is it increasing or decreasing? If it's increasing, which number is it going to converge to? You see, which is 8. So already we would know that it converges to 8. I hope we agree on this one. Do we agree on this one? So again, the last one would be we should find its limit, right? So finding the limit, guys, I'm gonna leave this one to you to find the limit of this. I want to see what you'll get. Find the limit using the part which I showed you on the first example. Find the limit of this. You'll send it in the group. I would prefer that you send it in the group so we can discuss it. So let's check the next question. We have this. Let me erase here so I can explain this in detail. So here they say this, right? They give us this. They gave us this question. They say show that lim as n approaches infinity of 2 to the n plus 3 to the n to all to the 1 over n is equals to 3. So for us to prove this by squeeze theorem, you should always keep in mind that since n is approaching infinity and n is a natural number, this will always be greater than 0. You see, right? It will never be less than 0. So you're going to restrict yourself to say right. Then what comes next is the smallest between these two should always be the one in the middle. You see, right? 2 to the n, then the biggest should be the one at the end, because the answer will always be the biggest base. You see, right? Then since we have this, now we're going to say for all n greater or equals to 1, right? Then now we need to do what? We need to change this middle part to be the same as this one, while we also change the left and right hand side. So if I add here, say 0 plus 2 to the n, no, I'm not supposed to add 2, I'm adding 3 to the n, I need 3 to the n. 3 to the n, which is less than 2 to the n plus 3 to the n, which is less than 3 to the n plus 3 to the n. This one would imply that 3 to the n is less than 2 to the n plus 3 to the n less than this plus this. There are 2, right? So I can write 2 times 3 to the n. This is the easiest method to use. So this would imply there are 2 and they're the same. So I can do that. This would imply that now I need to add the limit, or not the limit one. I need to add this part, or 1 over n. So I'm going to say 3 to the n times 1 over n there, which is less than 2 to the n plus 3 to the n to the 1 over n, which will be less than 2 times 3 to the n to the all over 1 over n. And then this would imply the n here would cancel this n, then I'll be left with 3, right? Which would be less than 2 to the n plus 3 to the n 1 over n, which will be less than 2 to the 1 over n, then 3 to the n, because the n would cancel the 1 over n. No, to the 3, man, because the n cancelled the 1 over n. So now I need to introduce the limit. Check this. Now I need the limit for this to be the same as this, right? So I introduce the limit. This will introduce that the limit as n approaches what? Infinity of 3. That's less than the limit as n approaches infinity of 2 to the n plus 3 to the n to the 1 over n will be less than, I take out the constant, the limit as n approaches infinity of 2 to the 1 over n. Over n. And this would imply that this side it will be 3, right? You know the limit of a constant is that constant. And this will be the limit as n approaches infinity of 2 to the n plus 3 to the n to the 1 over n. It should be less than 3, because this would give us 1. You see, so you know the limit, we would take this limit to the numerator, or to the exponent, and it would give us 0. And 2 to the 0 is what? A 1. So in that case, we have 1 over infinity. 1 over infinity would approach 0. So 2 to the 0 would approach 1. You see, right? So that's the case. So we can say, therefore, the limit as n approaches infinity over 2 to the n plus 3 to the n to all over 1 over n would be less than, or not less than, it will be equals to 3. You must write by what? By squeeze play theorem. We agree, right now? Is there any question? I believe that a question like this will come in a test. He likes to play with people's mind. He wants to see, do you really understand this thing, or you're just taking chances? Because this question teaches you to know that if you're dealing with sequences, this will always be the case, right? If the sequence is like this. So I want you to see that, okay, man, it can be like this. Or maybe you can bring maybe a certain question, maybe 0 to the n, minus 1 to the n, alternating like that, and wants to see what will you do. You see, right? It can happen. Such a case can happen. So, is there any question on this one before I can pass on this?
So I have a question.
Yes.
Like on the second step, like you introduce 3 to the power n. Let's say we introduce, but you 3 everywhere. Then on the following step, I don't understand to see what happened.
You mean here?
On those 3 to the power n plus yes.
Oh. So what happened here ne, is these 3 to the power n, there are 2, right? You agree, ne?
Yes.
So I'm just saying here, these are 2. You see? We have, I'm just saying these are 2. I'm having 2, 3 to the n.
Okay, thank you. Can I also see the question?
Here's the question. You see it, right?
Yes.
You see it, right? Okay, it's fine. Most I can pass, ne? Alright. So,
Yes, you can pass.
alright, thank you. So now we have this, right? They say the sequence A of n is defined by A1 is equals to this, then 5 A of n plus 1 is equals to this, right? Such that n is greater or equals to 1. Then they say by induction, prove that this is the case. So I put this here, I should have written try. I want you to try it. You see right now? So I want you to try it. So let's compute this. You should try this. So now we're given a question now. It's a bit similar to what we were doing before, right? But they were just saying, sure, it's increasing, and they gave us, let's say sometimes they'll say A is less than 3, then yeah, things like that. But there's a question where they don't give you such things, and they say, show that A of n is decreasing, right? So if they say it's decreasing and they didn't give you those things, you're going to come and say A of n plus 1 is minus A of n, right? So this would still take you to the solution, right? Then again, someone would decide and say, let me say A of n plus 1 all over A of n is greater. Is it decreasing? It's decreasing. It's less than 1. But I want you to use this. As long as they didn't give you this condition of A of n is less than 3 or something like that, I want you to use this. I want you to use this. As long as they didn't give you a condition, I want you to use this. So first we will try the one which we are using the most. Let's try it and see what it will give us. So we know A of n plus 1 would be a of n, not a of n, man. It would be n plus 1 all over n plus 1 squared plus 1 minus n over n squared plus 1. So that this is equals to, then we have here that this is n plus 1 all over n squared plus 2n plus 1 plus 1. This plus 1, the first one is coming inside here when I'm expanding, and the second plus 1 is coming outside here. Then this would be minus n over n squared plus 1. And this would be equals to n plus 1 all over n squared plus 2n plus 2, right now, minus n over n squared plus 1. And then now we need to find what's the solution to this, right? So we can even do this. We can say, so here's the problem, where the problem would be, right? So here what we have is, we don't have any value to plug here, right? That would check. We'd have to plug n is equals to 1, n equals to 2, n equals to 3, n equals to 4, you see right now? So it would be difficult for us to check whether this is increasing or decreasing, because they don't want you to plug manually. So that's why I'm saying that when you come here, I prefer that you use the one where you have all over n. So let's do that. So we can say a of n plus 1 all over a of n is less than 1, which this would imply that a of n plus 1 is less than a of n. Then I plug this. So I'll have n over n plus 1 over n plus 1 squared plus 1, which is less than n over n squared plus 1. And then I multiply both sides by this. Here I'll have 1 is less than n. So I'll just multiply both sides by n plus 1 squared plus 1 all over n plus 1. So if I also multiply by it on this side, it will give us 1. It will cancel out and we're left with 1. You see, right? So I see that this will be n times n plus 1 squared plus 1 all over n plus 1 n squared plus 1. We agree, right? Which this would imply, let me write it down here, would imply that 1 will be less than, if I simplify the numerator, let me simplify the numerator. I'll have n times n squared plus 2n plus 1 plus 1, which this will be all over n to the third plus n squared plus 1, which this would imply that 1 is less than n to the third plus 2n squared plus 2 all over n to the third plus n squared. Is it n squared? This one's not supposed to be. Let me check. N plus 1. So is this? Yeah. So plus n plus 1.
Sir,
Yes.
on top it
Must be what? Akani, you saying on top it must be? Or n here?
n to the third plus 2n.
It's fine now, right? Ne?
Yeah.
Alright, thank you. So let's check this. Which one between the numerator and denominator is bigger? Which one between the numerator and denominator is bigger? Which one between the numerator and denominator is bigger here? So the numerator is bigger. Check this. N to the third, they're equal. 2n squared, n squared. You see right now? So the numerator would become bigger as the numbers enlarge. So it means that hence a of n is decreasing for all n. You see right? Because the numbers here would be bigger than the first number. So than this one. So you see that I've already proven that this would be the case. So yeah. Is there any other question? Is there any question that we can any question? Or someone would decide this is the, I guess this is the first part which would work, right? Someone would decide and say, okay, let me just do it like this. How they do it, most lecturers, right? Some would say, let me just say, maybe I say a of n plus 1 over an is less than 1, right? Which this would imply. Then you write your equation first. You had your n plus 1 all over n plus 1 squared plus 1, which is less than n over n squared plus 1. Then someone would say this, would say that let me multiply this side by this, right? I'm multiplying this side by this, and I'm multiplying this side by this, right? So, or you cross multiply. So if I cross multiply, I would have this. I would have n plus 1 times n squared plus 1, which is less than n times n. Let me simplify this. This would be n squared plus 2n plus 1 plus 1, right? And this would imply that some multiply this by this, which is this one, right? And this by this, which is this. You agree, right? Just cross multiplied. Then this would be, would have, if I simplify this side, I would have n to the third plus n squared plus 1, which is less than this side. I would have n to the third plus 2n squared plus n plus n. You agree, right? So this would imply if I take n to the third to the other side, this would cancel. This would cancel this. And then n squared minus, or let me just write them to show that they would cancel, right? Because some they would miss out. I take n to the third to the other side. Then I have plus n squared, which is this. I subtract it with this minus 2n squared. Then I have this n plus n. I subtract it with this 2n. I'll have minus 2n. Then I say this is less than 0, right? This would imply that this would take off each other. Would have minus n squared minus n, which is less than 0. So for all n greater than 1, this would be true. Because if n is 1, we'd have minus 1, which is less than 0. If n is 2, we'd have minus 4, minus 2, which is less than 0. You see, right? So this is decreasing. If n is 3, we'd have minus 9, minus 3, which is also less than 0. If x was 4, we have minus 16 minus 4, which is also less than 0. We agree, right now? So here I was just showing you different methods that you can use. So which one do you prefer, the last one or the first one? But I think the last one is a little bit clear, right? Because you don't need the calculator to see. You can just say, oh, no, this is true. We agree, right now? So yeah. So even let me write here. Yeah. Any question? Yeah, this would be us, guys, closing the bounded and the increasing, decreasing sequences, and also so we're fine, right? Yeah, I'm gonna stop the recording.